Students, Assalamu alaikum. Welcome back to our new class. In the last module, that means the first module, we discuss about relational data model. That is a data model, one of the important data model available in the industry is relational data model. Its popular data model is a relational data model. In relational data model, we consist as each relations in a tabular format, that is having rows and columns. And also we discussed about relational algebra operations and relational calculus for retrieving the items in a relations. Now we discuss about next chapter, that means relational database design. Our second module is relational database design. For the design purpose, we need to know the functional dependencies and normalization of the database. Today we discuss about the informal guideline of the database design. Before going to move the topic, we look at the outline of this chapter. First, we look on informal guidelines of relational database designs. The mainly 4 guidelines we need to know before designing our database. Semantics of the relational attribute, redundant information in tuple and update anomalies, null values in tuples, spurious tuples, etc. What is a relational database design? What we look on we designing a relational database design. We know a relation is a grouping of attribute. Our aim is to this grouping of attribute to form a good relation. There are 2 levels of relational schema: logical or user level view and storage base level view. The first is the logical or conceptual level. How users interpret the relational schema and the meaning of their attribute. Having a good relational schema at this level enables users to understand, clarify the meaning of data in the relation and hence to formulate their queries correctly. The second is an implementation or a base level or a storage level. It is called a base relation. In this, how the tuple in the base relations are stored and updated. The design is concerned mainly with the base relations. As with many design problems, database design may be performed by using 2 techniques, bottom-up technique and a top-down technique. Bottom-up approach, that means design by synthesis method. Consider the basic relationship among individual attributes as a starting point and used to construct relation schemas. In this method, we mainly consider the basic relationship among the individual attribute and combine these to form a relation. This is not a popular in practice because the problem of having to collect the large number of binary relationship among the attribute as a starting point. Next one is top-down design methodology, design by analysis. Here we start with number of grouping of attribute in a relation that exist together naturally. Consider if you have a application form. The application forms are mainly many field. We combine these into a single relation. Then the relations are then analyzed and we split up into separate sub-relations according to the analysis. That is, if you have a large relation, then we decompose the relation to satisfy the desirable properties. This method is more appropriate and we use this type of design technique. basically relational database design having two techniques, bottom up and top down. Mainly we focus on top down design methodology. Next we look on informal guideline for database design. Mainly focus on four guidelines. Guideline number 1 is semantics of relational attribute, redundant information in tuple and update anomaly, reducing the null values in the tuple, and disallowing the possibility of generating spurious tuples. These are the informal measures of the quality of relational schema design. We look on each and every point. First one, the semantics of the relational attribute. Guideline number 1 shows each tuple in a relation should represent one entity or a relationship instance. That is, the guideline number 1 is design a relational schema so that it is easy to explain its meaning. Do not combine attribute from multiple entity type and relationship type into a single relation. Intuitively, if a relational schema corresponds to one entity type or one relationship type, it is straightforward to explain its meaning. Otherwise, if the relation corresponds to mixture of multiple entities and relationship and semantics, which will result the relation cannot be explained easily. So, we should remember the guideline 1 before designing a relational database. That means each tuple in a relation should be one entity or entity relationship instance. We cannot combine multiple entities into a single relation. This is the guideline number 1. Consider an example. Here the employee table having many fields which is referred only employee relation, and we have an foreign key D number which will refer the department number from the department table, and the department table having involved only the department field D number, D name, D manager number. Then department locations having the field D number and D location. Project having the primary key P number and foreign key D number. Works on having employee number, P number and hours. These are the well explained or well defined company relational schema. These are easily understood, each and every attribute in these tables. So, this satisfies the guideline number 1. Then next, guideline number 2, redundant information in tuple and update anomalies. Information may be stored in a relation having repeatedly. We call it as redundant information. This leads to mainly two problems. Storage space. Suppose consider we have large number of data, then the repetition of the tuples in a relation may leads to wastage of storage. Then another problem is acquired while redundancy is update anomalies, insertion anomaly, deletion anomaly and modification anomalies are the causes problem with update anomalies. We will explain each and every one. Consider an employee, consider a relational EMP project having the field employee ID, project e-name, p-name, number of hours. This is a relation. Suppose we need to change the project number from P1 from billing to customer accounting. Then this will may cause the update of maybe 100 or 1000 employee working on a project P1. Anomalies having three problems: insertion anomaly arising, deletion anomaly arising and modification anomaly. First we look on insert anomaly. Consider a relation employee project having the field employee, project name, e-name, p-name and number of hours. We need to insert a project unless an employee is assigned to it. നമുക്കറിയാം നമ്മളുടെ എംപ്ലോയി സപ്പോസ് എനിക്കൊരു പ്രൊജക്റ്റ് കിട്ടി എൻ്റെ കമ്പനിക്ക്, ഞാൻ ആ പ്രൊജക്റ്റ് ഡാറ്റാബേസിലേക്ക് എൻ്റർ ചെയ്യണം. ആ സമയത്ത് ആ പ്രൊജക്റ്റ് ആർക്കൊക്കെ ഞാൻ അസൈൻ ചെയ്തു എന്നുള്ളത് ആദ്യം തീരുമാനിച്ചിട്ടില്ല. പ്രൊജക്റ്റ് കിട്ടി, ആ പ്രൊജക്റ്റിൻ്റെ ഇൻഫർമേഷൻ എനിക്ക് ആഡ് ചെയ്യണം. അങ്ങനെയാണെങ്കിൽ ഞാൻ ഈ EMP പ്രൊജക്റ്റ് എന്ന് പറഞ്ഞ ടേബിളിലേക്ക് ആഡ് ചെയ്യും. ആ സമയത്ത് നമുക്ക് എന്ത് സംഭവിക്കും? എംപ്ലോയി ഫീൽഡുകളെല്ലാം ബ്ലാങ്കായി വരും. ഇത് ആണ് ഇൻസേർഷൻ അനോമലി. ദാറ്റ് ഈസ് ഇറ്റ് ഈസ് ഡിഫിക്കൽട്ട് ടു ഇൻസേർട്ട് എ പ്രൊജക്റ്റ് unless an employee is assigned to it. Similarly, we cannot insert an employee unless he or she is assigned to a project. Sometimes it leads to a inconsistency problems in the relational schema. This is an insert anomaly. Then delete anomaly. In the same table, employee, project, e-name, p-name and hours. Suppose a project is removed from the database. This may result deleting all the employee who work on that project. This will cause a major consistency problem. Suppose we need to track the employees details. This is not possible in this case. Alternatively, suppose we need to remove an employee from the table. This may lead the project details also. This is an delete anomaly. Another two examples having the insertion and deletion anomaly and update anomalies. Consider an EMP department table. Here the field e-name, SSN is an employee number, B date, address, D number, D name, D manager, SSN. It is, suppose if you have a new employee comes into our company, we need to insert the employee in this table. That time there is no department assigned to it. That in this case, an employee department table having null field in D number, D name, D manager, SSN. This is the insert anomaly problem. In the same manner, suppose we have lost a department. നെക്സ്റ്റ് പ്രോബ്ലം വരുന്നത് എവിടെയാണെന്ന് വെച്ചാൽ, ഇപ്പോൾ എനിക്ക് എൻ്റെ കമ്പനിയിൽ 10 എംപ്ലോയീസ് ഡി നമ്പർ, അതായത് 101 എന്നുള്ള ഡി നമ്പറോട് കൂടിയിട്ടുള്ള 10 എംപ്ലോയീസ് ഉണ്ട് എന്ന് കരുതുക. ഈ 10 എംപ്ലോയീസും ഒരു ദിവസം കൊണ്ട് ടെർമിനേറ്റ് ചെയ്തു പോയി, ടെർമിനേഷനോ ഓർ ഒരു റിസൈൻ ചെയ്തു പോയി. പക്ഷേ എൻ്റെ ഡിപ്പാർട്ട്മെൻറ്റ് സ്റ്റിൽ അവിടെ എക്സിസ്റ്റിംഗ് ആണ്. അപ്പോൾ ഞാൻ ഈ എംപ്ലോയീസിനെ റിമൂവ് ചെയ്യുന്ന സമയത്ത് എൻ്റെ ഡിപ്പാർട്ട്മെൻറ്റ് ഡീറ്റെയിൽസും കൂടി അൺഫോർച്ചുനേറ്റ്ലി ഡിലീറ്റ് ചെയ്ത് പോകും. ഇതൊരു ഇൻകൺസിസ്റ്റൻസി പ്രോബ്ലമാണ് ഈ തരത്തിൽ നമ്മൾ ഡാറ്റാബേസ് ഡിസൈൻ ചെയ്താൽ. അപ്പോൾ അതുകൂടി റിമൂവ് ചെയ്യത്തക്ക രീതിയിലായിരിക്കണം നമ്മൾ എന്ത് ചെയ്യേണ്ടത്, ഡാറ്റാബേസിനെ ഡിസൈൻ ചെയ്യേണ്ടത്. സിമിലർലി ദീസ് പ്രോബ്ലം ഈസ് അറൈസ്ഡ് ഇൻ എംപ്ലോയി പ്രൊജക്റ്റ് ടേബിൾ. ഇവിടെയും അത് തന്നെയാണ്, മൾട്ടിപ്പിൾ ഡിപ്പെൻഡൻസീസ് ഉള്ളത് കാരണമാണ് ഇങ്ങനെയുള്ള ഡിലീഷൻ അനോമലീസ് എല്ലാം വരുന്നത്. 2. Design a schema that does not suffer from the insertion, deletion and modification anomalies are present in the relation. If there is any anomalies present, then note them so that the application can be made to take them into account. That is, we need to operate correctly. This is the guideline number 2. While we designing a database, we need to check the insertion, deletion and update anomalies. If sometimes it is in present, we need to solve an appropriate application for that. Next, third one is null value. Guideline number 3. Null values. Mainly null values are arised for 3 types. Sometimes some attributes are not applicable or invalid. In that case, we have a null value. For example, if some people's having 2 phone numbers, then we put 2 phone number field in our table, but one people having only 1 phone number, then another one is blank. Then the blank statement we replace with null value. Then another one is multiple degrees holding. All and every person have not multiple degrees, but some people have multiple degrees. In that case, we put the other field value to null. Then sometimes the attribute values are unknown. The attribute value we need not know. That case we put null value in that place. Then value known to exist but unavailable. That means sometimes we forget to type the value in that column. This may cause the value null. These are the 3 types when null values arises. The guideline number 3 is relation should be designed such that their tuple will have a few null value as possible. That is, as far as possible, avoid placing attribute in a base relation whose value may be frequently be null. In some cases, if the null are unavoidable, make sure that they apply in exceptional cases only and do not apply to majority of tuples in the relation. And also we check our primary key is not null value. These are the guideline number 3. Then 4th one is generation of spurious tuples. Suppose we have 2 relations, employee location having the field e-name and location, and employee project 1 having the field e-number, p-number, hours, p-name and p-locations. If you want to join these 2 relations, this will lead so many tuples that are not present in these 2 relations. We call it as it is a spurious tuples. The guideline number 4 is the relation should not be designed to satisfy the lossless condition. That is, design a relational schema so that they can be joined with equality conditions on attributes that are either primary key or foreign key in a way that guarantees no spurious tuples are generated. Avoid relations that contain matching attributes that are not, for example, foreign key or primary key combination, because joining on such attribute may produce spurious tuples. ഗൈഡ് ലൈൻ നമ്പർ 4 എന്താ പറയണമെന്ന് വെച്ചാൽ, നമ്മൾ 2 ടേബിളിനെ ജോയിൻ ചെയ്യുന്ന സമയത്ത് നമ്മൾ അതിൻ്റെ പ്രൈമറി കീ ഫോറിൻ കീ കോമ്പിനേഷൻസ് വെച്ചിട്ടായിരിക്കണം നമ്മൾ ജോയിൻ ചെയ്യേണ്ടത്. അല്ലാതെ നമ്മൾ ജോയിൻ ചെയ്താൽ നമുക്ക് ഒരുപാട് ടപ്പിൾസ് ജനറേറ്റ് ചെയ്യും. ഈ 2 ടേബിളിലും ഇല്ലാത്ത ഒരുപാട് ഡാറ്റാസ്, അതിനെ നമ്മൾ ലോസി ജോയിൻ എന്നാണ് പറയാറ്. അങ്ങനെ വരാതിരിക്കാൻ നമ്മൾ ശ്രദ്ധിക്കണം. അങ്ങനെ വരുന്ന സമയത്ത് നമുക്ക് ജനറേറ്റ് ചെയ്യുന്ന റിലേഷൻസിനെയാണ് നമ്മൾ എന്ത് പറയണത്, സ്പ്യൂരിയസ് ടപ്പിൾസ് എന്ന് പറയണത്. അപ്പോൾ അങ്ങനെയാണെങ്കിൽ നമ്മൾ ഡീകമ്പോസിഷൻ നടത്തുമ്പോഴും അല്ലെങ്കിൽ ജോയിൻ ചെയ്യുമ്പോഴും ശ്രദ്ധിക്കേണ്ട കാര്യങ്ങൾ എന്താണെന്ന് വെച്ചാൽ, നമ്മൾ നോൺ അഡിറ്റീവ് ഓർ ലോസ്ലെസ് ജോയിൻ ആയിരിക്കണം, ഡിപ്പെൻഡൻസി പ്രിസർവിങ് ഡീകമ്പോസിഷൻസ് ആയിരിക്കണം നമ്മൾ എടുക്കേണ്ടത്. അല്ലെങ്കിൽ നമുക്ക് ഇതുപോലുള്ള സ്പ്യൂരിയസ് ടപ്പിൾസ് നാച്ചുറൽ ജോയിൻ ചെയ്യുമ്പോൾ വരും. ഇത്രയാണ് നമ്മുടെ ഇന്നത്തെ ടോപ്പിക്. Today we discuss about the initial conceptual design of a database. Mainly 2 types of database, top down and bottom up. And we discussed about some of the informal guidelines of the relational database design. Thank you students for watching this.